Now that you know how to draw angles in degrees, it's time to learn how to draw angles in radians. Keep in mind that when we are drawing angles in degrees, I'm going to scooch it over here, we start at 0 and then we make our way around the circle to 360 degrees. Because in the unit circle, we know that a circle has 360 degrees. It didn't just come out of nowhere. Same thing for radians. Radians are measured in pi. And because the circumference of a circle is given to us by 2 pi r, which is, I'm going to write it right over here, we know that the circumference is 2 pi r, and in a unit circle, the radius is just 1, hence the name unit circle. That means that one full rotation is going to be 2 pi. So 2 pi radians is equivalent to 360 degrees. So I'm just going to scooch it back right over here, and we're going to label the quadrantal angles in radians. We're starting at 0, and we're ending at 2 pi. In the unit circle, the halfway mark is right here because that creates a semicircle. Half of 2 pi is just 1 pi. That's how I remember it. And then I cut them in half again. So halfway between 0 and 1 pi is 1/2 pi, or we're going to write that as pi over 2. And halfway between 1 pi and 2 pi is 1.5 pi. But we can write that as an improper fraction, which is 3 pi over 2. We always want to write those improper fractions if you could, please, unless it simplifies to whole numbers. Now, in the unit circle, we know degrees. You just learned radians. And I also want to go ahead and write in the quadrantal angles. I know we did that in class. If you're a remote learner, you're going to see a video where we do this later on. But in the unit circle, so it looks something like this. Here's my circle. Not to scale, obviously. Oh, gosh. There you go. It's beautiful. Pretend that was to scale. There's a radius of 1. So any point that connects the center to the outside of the circle, you can draw a line. So this is a radius, 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 whatever, you get the idea. Because it's a unit circle, I know that the radius is 1. So if I wanted to write the coordinates of 0 degrees, it's right 1 unit, so that's 1, 0, because I didn't go up or down. X, comma, y. To get the coordinate of 90 degrees, or pi over 2, that's going to be up 1, so 0, 1. To get the coordinates of 180, or pi, that's left 1. Now moving left is a negative movement affecting the x value, so it's -1, 0. And lastly, at 270, or 3 pi over 2, we are moving down 1 from the center, so that would give me a coordinate of 0, -1, because moving down is a negative movement. Okay, so now you know all of the quadrantal angles in degrees, in radians, and its actual coordinates. Now we're going to take a look at example 5. That's drawing angles given a measure in standard position. And it's very similar to how you did it in degrees. You always want to start off by drawing your coordinate plane. So, here's my coordinate plane. And just like how you would typically go 0, 90, 180, 270, 360, I'm going to do that with the radians because my theta is in a radian. So that's 0, pi over 2, pi, 3 pi over 2, 2 pi. 5 pi over 6 doesn't really look like this though. It's something over 6, so we're going to have to rewrite all of our quadrantal angles as something over 6. The easiest ones to do first are pi and 2 pi. So if I want to rewrite 1 as something over 6, that would be 6 pi over 6, because 6 divided by 6 is 1. And if I want 2 pi to become something over 6, I would have to double 6. So 12 pi over 6. And 0 is just 0 still. And now we ask ourselves the same questions as before. What's halfway between my values? So halfway between 0 and 6 is 3. So that's 3 pi over 6. Notice how 3 over 6 is 1/2. Halfway between 6 and 12 would be 9. And notice how 9 over 6 does simplify to 3 over 2. So that's just a way you can check it real quick. If I'm going to draw something in standard position, that means we're going to start with our point in the center. This is extending towards positive infinity. It's my positive x-axis. So that's always going to be our initial side. Our terminal side we get by rotating theta. So I'm starting here, and because it's a positive 5 pi over 6, I'm going to rotate in a counterclockwise rotation, just like we did before. So I'm going this way. And I want to go and stop at 5 pi over 6. So just looking at that, I can see 0 to 3 pi over 6. That's not far enough. I need to keep going because 5 is greater than 3. But 5 is between 3 and 6. So I know that this theta is going to land in quadrant 2. 5 is a little closer to 6 than 3, so I'm going to draw it right about here. That's my 5 pi over 6. Another way you can think about it is that if it's over 6, between 0 and pi, that means it's cutting pi into 6 different slices, if you will. Here's 1, 2, 3, 4, 5, 6. So that's why it's 5 pi over 6. I just think it's easier to rewrite the fractions than having to worry about drawing them. Next, right off the bat, just by looking at it, this is a negative theta. So instead of moving in a clockwise, or excuse me, a counterclockwise rotation, we need to move in a clockwise rotation. So this would be 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Just like what we did before with negative degree measures. It's just now we have the extra step of rewriting the fractions so it's over the same thing. So now we want the denominator to be 4. Okay, well, it starts at 0. Double of 4 is 8, so this is negative 8 pi over 2, or excuse me, 4. And then this over here would be negative 4 pi over 4. Just double check if you want. Negative 8 divided by 4 is negative 2. Negative 4 divided by 4 is negative 1. Looks good. Halfway between 0 and negative 4 is negative 2. And it's over 4, remember. Halfway between negative 4 and negative 8 is negative 6. Remember, we've changed the denominator to 4. So now, if I want to draw a negative 1 pi over 4, I'm going to start in standard position. So there's my initial side. I'm going to rotate in a clockwise rotation a negative 1 pi over 4, which is right there. Because negative 1 is exactly halfway between 0 and negative 2 pi over 4. So make sure that you draw your angle right here so that the terminal side is cutting quadrant 4 in half. Just a side note, you could have also found a positive coterminal angle between 0 and 2 pi to draw this angle. And I'll show you how to do that, but we did something similar with degrees. Okay? Now we're going to draw 23 pi over 12. Let's just do the same thing, and it's positive, so let's just label it like we normally do. That gives us a good foundation on where to start. And then we're going to rewrite it so that it has the same denominator. So I'd like to usually do pi as 12 pi over 12 and 2 pi as 24 pi over 12, because 24 over 12 is 2. Halfway marks, so 0 to 12, halfway would be 6. And 12 to 24 would be 18. So these in green, that's my new degree measures. We're starting in standard position, so there's my initial side. Because it's positive, I'm going to go in a counterclockwise rotation, and I'm going to stop at 23. So I'm starting here, I go from 0 to 6, but still not enough. 12, 18, and I almost get to 24, but not quite. I'm going to stop really close, and there's my theta, 23 pi over 12. Okay, let's talk about coterminal angles. So when we were doing it in degrees, you would do plus or minus 360 degrees. But we've established in the beginning of the notes that 360 degrees is the same thing as 2 pi. So now, instead of adding or subtracting 360, we're going to add and subtract 2 pi. This portion of the notes just asks you to draw 5 pi over 6 and negative 7 pi over 6. I'm just going to show you what that looks like. So here's my 5 pi over 6, and here's my negative 7 pi over 6. It's just reiterating the fact that coterminal angles are angles that are in the exact same position. So you can see how our initial sides are the same and our terminal sides are in the exact same location. So once again, if we were doing it algebraically, we're going to be adding or subtracting 2 pi in order to get these coterminal angles. Example 6 is finding those positive and negative coterminal angles. Once again, adding or subtracting 2 pi. So if theta is 5 pi over 3, to find a positive coterminal angle, I'm going to do 5 pi over 3 plus 2 pi. Now, I can't go ahead and add these straight away. In order to add, you must have a common denominator. So I'm going to have to multiply this by 3 over 3. So really what I have is 5 pi over 3 plus 6 pi over 3, or 11 pi over 3. If I would like to list a negative coterminal angle, I'm going to go ahead and subtract 2 pi. So really that's 5 pi over 3 minus 6 pi over 3. And that gives me a negative pi over 3. So just to recap, for part A, we really were adding or subtracting 2 pi, but because of the denominator, we were adding or subtracting 6 pi over 3, which is equivalent to 2 pi over 3. We're going to use this idea in example B, so that's the second video.